I just have a couple more examples of graphing linear inequalities. When you see this first one, the first thing you have to do is solve for y. To graph in slope-intercept form, using the slope and the y-intercept, we need to put it in that form first, which is y by itself. You've got to remember that the minus is attached to the y, making it negative. Therefore, I need to get rid of the positive 3 by subtracting it. Let's bring all of this down because I'm not really subtracting, I'm just moving. Now what's in front of the y? Isn't it an imaginary 1? So I'm dividing by negative 1. When I divide by a negative, I must flip the inequality because it changes the order. And then now, hopefully you know your negative, your integer rules, and we have made this 5x plus 3. So let's graph it. Let's go to 3 on the y-axis, and let's go up 1, 2, 3, 4, 5 over 1. Remember that when I'm graphing the slope and I have a whole number, I have to have a rise over run. So I have to put it over 1. My rise over run is 5 over 1. Is this a dashed line or a solid? Well, it can be greater than, but not equal to. So it's a dashed line. And then where is the y greater? Well, here's my y-intercept. If I go up this y-axis, I'm getting greater. So I've got to shade this side of the line. All of the points on this side of the boundary line would be solutions to this. Let's check one that's not in the shaded part. Let's check 0, 0. So I'm going to go to the original equation. I like to just write down the shell, leaving a hole for x and y. I'm going to put in 0, 0 because the math's easy. I get 3 is less than 0. Is that true? No, it is not true. So 0, 0 is not in the shaded area because it's not a solution, so I have shaded correctly. Let's go ahead and test one that is in the shaded area. Let's test, negative 2, negative 2. I'm just going to pick that point. So let's go to the original equation. And we're going to say that x is negative 2 and y is negative 2. We're going to get 5 less than 10. Is that true? Yes, it is. So yes, that is a solution. Negative 2 is in the shaded area. It's a solution. Let's check just one more. Let's check, just to show you the math, let's do negative 1, 1, 2, 3, 4, 5. How's that? Negative 1, 5. So negative 1 goes where the x is, right there. I'm substituting for x. Negative 1, 5, 5 goes where the y is. So now 3 minus 5 is negative 2. Negative 5 times negative 1 is positive 5. All negatives are less than positives. So yes, negative 2 is less than 5. So the point negative 1, 5 is a solution. Let's do one more. It's not in standard form. Let's get the y by itself and let's subtract 10x. 8y is less than or equal to negative 10x plus 64. The next step is to divide everything by 8. I'm going to reduce this to make my counting of my slope easier. So I have negative 5 over 4x plus 8. I did not divide by negative, I divided by a positive. Therefore, I did not have to flip my symbol. So let's go 1, 2, 3, 4, 5, 6, 7, 8. And then down 5 and over 4, because as Slope Dude would say, it's a nice negative. This has to be negative. If you don't have a negative when you finish graphing, you've done something wrong. This time it can be equal to the points on the line, so I have a solid line. And it's less than. I want where y is getting less. Well, right down here as we go down, we get to the negatives and y is getting less. So let's shade this whole side of the line. all the points in the shaded part are solutions. So I'm saying that the point 0, 0 would be a solution. Let's check and see. I'm going to run into my other problem here because I wrote too big. So 0, 0. If x were 0 and y was 0, I would have 0 is less than or equal to 64. Well, that's true. So 0, 0 is definitely a solution. Oh, let's check one more. Let's check, how about 1, 2, 3, 4, 2? Negative 4, 2. Let's check that one. So instead of x, I'm going to put negative 4. Instead of y, I'm going to put 2. I'm going to have negative 40 plus 16, negative 24. All negatives are less than positives. So isn't that true? Yes. So my point negative 4, 2 is a solution. And I could go on and list all those points in the shaded area to infinity, but anything not in the shaded area is not a solution.